Cool. So we're recording. Welcome everyone. So what we're going to do in this lesson is just go over a database design for keeping trade data. So how you would interact with the database, given there are many programs going on. So let me explain what the problem is, right? So essentially, let's just actually get a pen. So essentially, what's going to happen is, right, you are trading. So maybe, you're trading in the stock market or whatever, or the crypto markets, and you want to trade. So you need some record keeping here. So, you make trades like this, you make trades like this and that. And then all these, right, they'll just sort of go into some record. Typically, this is a database. This is a database. Now, you also, so you trade, and then these trades go into the database. You also want to have other programs, right? Now, this guy here, this other program could be watching. So these are some eyes. Those are some eyes, and he's watching the trades. Maybe there is a reconciliation program. We'll just call it recon, and it sort of watches all the trades, but it can also do a little bit of updating if something is suspicious in our database, right? So the thing here, we see many things are touching the database. We've got 1, 2, 3 programs touching the database, which is not at all the best practice, not at all the best practice. So let me show you sort of a alternative way of designing databases and stuff like that. Now, you could actually design this in any situation, like any context. Like, it doesn't have to be trading. It could be money management, or like sending notifications to people or stuff like that. So here, let's do this. Let's create a nice big box, and let's call that the front end. So that's a program. And then let's say there's a database here, right? Yep, a database, right? Okay, so, and then let's leave it at that. So what's going to happen is the front end needs to look at the data in the database. Essentially, that's easy. That's what's going on. Now, we don't want the situation where we touch the database directly. So what do? We make an API layer. Right? So this is just some REST endpoint. And in the API layer, we have CRUD. So create, read, update, delete. And that's what that is. So every time we want to create, read, update, delete any data at all, we always have to go through this API. And then the API layer is the only thing that can touch the database, right? So why would you need this? So say, for example, we have 2 programs, right? Maybe we have a front end, and maybe we have a risk manager, right? Manager. And what's going on is perhaps there's a button on the front end here that says, we'll just say reduce position, right? And then also in our risk manager, there could be some other button that says reduce position. Now this, or some program, right? Or just some Python program that automatically reduces the position. Let's go with that situation actually. Now, what could happen is if we are not careful, we could hit this reduce position because we see it on our end, right? We could hit this reduce position at the same time this automatic program automatically reduces the position in the database. And what this API layer does, it's sort of like a shield. So you can sort of code in here, oh, we've got 2 of these same events happening, only do it once, right? Only do it once. Or we could have another program that is reconciliation, right? And perhaps it needs to delete some trades. So that's the D in CRUD. And what we can do is put some protective layers here, because deleting is quite dangerous. So So maybe if this program sort of you didn't code it correctly and you end up doing some while true loop, right? And you know what while true does? You end up just running this loop forever. So maybe this program is stuck in some while true loop because of your bad coding. Now, what would happen is if this touches the database directly, it could just start deleting, 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 deleting. Now, if it goes through the API layer and then it goes into the database, there's code here that sort of gives us a little bit of protection. It gives us a little bit of protection there. So in case we are sort of stuck in here, what the API layer can do is like, oh, it's sending so many requests, and it just can like this will not stop because it's you've got to find that. But what the API layer will do is it will just sort of block. It'll just block that there. It'll just create a block and say, hey, stop that now. Okay. Now I want to talk to you about sort of we get these trades, but it's a bit slow. So I want to talk to you about real-time data and perhaps come up with another architecture for this, right? So let's think about this. So we've got our database, right? Bang, bang, bang. And we've got our API layer. We've got our API layer. Yep. And I'm going to split that into here. I'm just going to, it's a weird shape. Just go with it for now. Just go with it for now. It'll work. It'll work. It'll work. So, okay. And then we've got our front end, right? We've got the front end, and this can be, you know, a screen over here, right? Now, say we have a dashboard, and this could be your trades dashboards, right? T for trades, and then maybe you could have prices. So this could be just a view of all the prices, right? So for example, you've got, you know, BTC, like ETH, and then you've got some price associated with, and that could be, I don't know, Solana perhaps, and you've got some price associated with that. Now, there's two things going on. We want to capture trade data, which is actually, let's say it only comes in like a new trade only comes in once every 5 seconds, for example, right? Now, what we do for the trades is we use REST. We use REST, right? So that'll be some JSON we send, and then we get some JSON back. So that's like kind of slow, like, you know, 5 seconds, 5 seconds. But there is a situation where we want to stream prices. Now, the price of Bitcoin is literally changing all the time. Like, it's every nanosecond there's a different price, right? Every nanosecond there's a different price. So what you would do here is you use some sort of streaming protocol. Streaming. Now, the most common one on crypto exchanges is WebSockets. WebSockets, right? WebSockets. So what you would do, how would you go about doing this, right? Because there's a few things you could do here, right? You could have a trades table in your database with all the trades, and then you could have a prices table in your database, right? Bang, 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 bang. Prices table. And then this, right? You don't add prices to it. You actually update each price. However, this can be slow and expensive. So imagine you deploy, so every time you do a read or a write, it costs money. If you deploy your whole trading infrastructure on AWS, Microsoft, or whatever, every time you do a read or write, it's going to cost you a bit of money. So imagine if every second you are essentially just looking at the price or updating the price. Now, 1 second is actually quite slow in trading. So imagine if you did, let's say 1 millisecond, right? So that's 1,000. That's like a 1,000th of a second. So that means you times the number of requests by 1,000 if you are updating the price, you know, every second. And you know what that means? Times 1,000 monies. Times 1,000 monies. So that is the problem with keeping a prices table here. Now, you can keep a prices table and then sort of update it very slowly. But what I suggest you do is have, instead of a database, right, you have a cache. Now, what is a cache? A cache is just sort of an in-memory structure, right? That you run and you can quickly access things, right? Because if you're accessing prices from here, this number, if you drill down into it, it's actually written to a file. And reading and writing from a file is called a syscall, which is actually quite slow. But if we store the prices in memory, it's much faster than reading and writing to a file. So what you would do is you'd have some sort of cache. You can think about it as a database, but it's actually in memory. So you have some memory, and then yeah, actually it's more like that, right? The RAM. And so you take these memory bits. You can have things that update it, other programs that update it, and then you have this thing that sort of reads it in real time, right? And you can also have things like on update, read read the new price. So that's what you would do. So to summarize, you would use the trades which are slow for inside your database. But if you have something more a little bit high frequency like the prices, you'd use the cache. Now, there's two ways of building building a cache, right? You can sort of have a big, like, so you go to C++ or Rust or something like that. You have some sort of big array of memory structure, right? And what you do is you'd encode things in bytes, and then everything is just bytes essentially. So for example, you want the price of Bitcoin, maybe it's a float, that I've it's a float, so the first 4 bytes is like the float or something like that, and then you'd encode the price there, and then maybe the price of Ethereum would be the next one, right? Next one, and it'd be encoded like that, and you'd come up with some encoding, and you'd have your updating program coming in there, writing it, and then you have your reader program coming in there, reading it, and of course you need some sort of API to interact with this structure here. Another quick and dirty one, especially when I'm coding stuff in Python and I don't want to go like full serialized, deserialized things in Rust or C++, or even Go, or even do this in Python. Um, you can use Redis. Redis is pretty awesome. So you think about Redis, and so it's just a cache, right? So here, so say for example, is Redis. You've got a program. You've got a program. You got a program. So maybe you'd have one that's sort of updating it, and then it's really simple. It's just sort of you call some method like dot set. Like Redis comes with its own library in Python. You call dot set, and whatever you want whatever the name of it is, it's all like key value stores. So maybe like price, the key could be price, and you say I want to set it to 40, right? And then once that's set to 40, you can have things here. So you could put this in a loop, and then every, I don't know, 100 milliseconds or every millisecond, you'd call dot get here, dot get price, right? And then it's really simple. And then it'll just return whatever the number here is, which is 40. And it sort of takes care of all that multi-threading stuff, and using different threads and all that. So that's what I do. I use Redis if I was going to make some sort of cache, and yeah, just update the price like that. So this, I think I'm going to end the lesson right here. This is yeah, it's interesting. So when you make these sort of programs, you've got to really think about the design um, of your thing. I think just take a piece of paper or electronic pad or whatever, draw it out like this, and think about the components you're going to be making. So what I'm going to do in tomorrow's lesson is sort of I believe I'm going to sort of make a very like a static. I think I'm going to attempt to make a static analysis thing. So what I'm going to do is I'm going to make a single Python program. So a single Python program that will pull the data, and then do some analysis on it, right? Do some analysis. So, and then what we're going to do is once that is built, that might take a couple of lessons, couple of days, but we'll get through it. Once that is made, we're going to translate it into this design right here. We're going to translate it into this design here. So, and then that'll probably take, a few more lessons after that. So that is sort of the plan of these daily lessons. Yeah. So, if you learn something, if you have any questions, just leave it in the school community. Let me know. And yeah, good luck coding, everyone.